Okay, this is a EdXL vectors question that covers some nice little bits, especially to do with the lengths and sizes. So, first part we are asked to write as a column vector, which is similar to what they've got down here with the x over the y, technically over a z as well if you need it. And it describes a distance and a direction together. Particularly the distance from A to B and A to C. They're both given with two vectors we've been given in our problem. The question is to describe how to go from B to C. So vector B to C can be written as the sum of any vectored story that will take us by any route back from B to the place C. So first of all I want to do from B to A. That will get me to A, then from A I want to get to C, so I add to that the vector AC. So the story actually, you should find pairs in the initial version that you can cancel out and you'd wind up with just the BC. Unfortunately I don't know vector BA, but I do know its partner AB, and AB is the negative part of BA. It's the opposite, it goes in exactly the opposite direction. So when I come to add these two vectors together, I am going to do minus AB, minus 3, minus 2. When you're adding vectors, remember they add in position. So we're going to add to it 4 and minus 1. And this gives me a resulting vector of 1 minus 3. The second part, we're talking about find the length of the line CE. So we've still got the same problem. We have to be able to describe the position or the line C to E using vector notation of describe a number, and then we've got to work out how can we calculate the size of this. So first of all let's find the vector CE, and it needs to be done in terms of things that we know, and at the moment we don't know BE or CD. What we do get told is CD is two lots of AC. So AC is 4 minus 1, so this vector here, CD, is twice as big. Twice as big, same as adding a vector to itself, means we do 2 times 4, 8, 2 times minus 1, minus 2. So the journey I can do relies on me knowing that BECD is a parallelogram. That means if I can do the vector BC, which we've already done, I know the vector ED. If I know the vector CD, I know the vector BE. So I can do it as either combination. And I can do a journey either of CE is CD plus CE. And we know CE is minus the vector BED. And ED is the same as the vector BC because it's a parallelogram, it's parallel and equal sides. So this vector is also equal to CD, which we've just calculated as 8 minus 2. Add on the negative form of I want to talk about C here, for it should be DE. So this is the negative form of ED, and the negative form of ED is the negative of BC. So we're adding on minus 1 plus 3, the opposite of our previous answer. Add those together and we get the vector 7, 1. If we then turn this into our components, we've got an x component, which is 7, and a y component that is 1, and the assumption that we're using a Cartesian grid system, we've got a right angled triangle where the length is the Pythagoras hypotenuse. So the modulus of CE squared is the square of the two components, the x component squared and the y component squared, taken from the vector. So the length of CE is the square root of 49 plus 1 is 50. Now normally I would take an accurate answer, i.e. 5 root 2. Five squared is 25 times 2 goes inside the bracket. Calculate that, and they notice they want it to 2 decimal places. So the square root of 50 is 7.07106. 7.07106. It said it wants 2 decimal places in the answer. So 2 decimal places is 0.7. Check the 1 that goes downwards, says round down. So we only want the 7.07 units. Okay, that's the solution.